Hello. In this video, I am going to discuss about one derivation, that is path of contact in gears and gear trains. So this is a topic from Kinematics of Machinery. So what is the path of contact? Path of contact is nothing but it is the locus of the point of contact between the two gears. It is the locus of point of contact between the two gears from the beginning of engagement to the end of the disengagement. For example, if you see here this one is the pinion. I am indicating the pinion with number 1, and this one is the gear. I am indicating the gear with number 2, right? Here if you see this circle is the base circle of the pinion. Similarly, here I am also having one more circle. This circle is the base circle of the gear. If you draw tangent to these base circles, if you draw a tangent to the base circle 1 and base circle 2, then this is the tangent to these two base circles. The tangent to these base circles is I am indicating with EF. The force from the pinion is transmitted to the gear along this direction EF. So this one is called line of action. This one is called line of action. And if you see here, this one is the addendum circle of pinion, and this one is addendum circle of gear. This addendum circle of the gear is touching the line of action at point C. Addendum circle of the gear is touching the line of action at point C. Similarly, addendum circle of the pinion is touching the line of action at the point D. So this CD is nothing but the path of contact. It is the locus of point of contact from the beginning of engagement to the end of the disengagement, and beginning of engagement is C and end of the disengagement is D, and this CD path we call it as path of contact. And from the point C to the pitch point, this distance we call it as our path of approach. CP is called path of approach and PD is called path of research. The total CD is called path of approach plus path of research, that is path of contact. So we need to find out this path of contact, the length CD, in terms of the radius of the gear as well as the radius of the pinion. If you see here, this line is perpendicular to the line of action, from the center of the pinion. And here this line is perpendicular to the line of action from the center of the gear. So, and here this P to B is nothing but a capital R, that is pitch circle radius of the gear. And similarly here, from point A to P, that is smaller is nothing but pitch circle radius of the pinion. Small r is pitch circle radius of the pinion, and capital R is pitch circle radius of the gear. And here the angle is pi, that angle is pressure angle. So by using this triangle theorem from BPF, we can indicate that this is capital R cos pi and this one is small r cos pi. And the distance from point A to D, is RA, addendum circle radius. This one is addendum circle. The distance from the circle to the center is addendum circle radius, and I am indicating with small RA. Similarly here, the distance from the center to the addendum circle of gear, this is addendum circle of gear. The distance from center to the addendum circle of gear, that is BC. BC is also I am indicating with capital RA, addendum circle of the gear. Small RA is addendum circle of the pinion, capital RA is addendum circle of the gear. And this R cos pi, R sin pi you can easily indicate from the triangle BFP. From triangle BFP, here I am having right angle triangle, so BP is a right angle triangle, and adjacent side is R cos pi, opposite side is R sin pi. Similarly here also, adjacent side is R cos pi and opposite side is R sin pi. This is the diagram. If you can able to draw this diagram, we can easily do that derivation easily. So the path of contact is nothing but CD. CD is divided into CP plus PD. CD is divided into CP plus PD, and CP is path of approach, PD is path of research. And I can write this CP like CF minus PF. CP I can write it as CF minus PF. Why we are writing it? We have to write in terms of the diagonals of the diagonals or sides of the triangles. If we write in terms of the sides of the triangle, then we can easily write in terms of radius, right? That's why I'm writing CP as CF minus PF and PD as DE minus PE. PD as DE minus PE. So this CF and PF I can write like in terms of capital R and small r. CF is nothing but, if you see here, CF is nothing but it is the opposite side of the triangle FBC. It is the opposite side of the triangle FBC. In this, BC is the hypotenuse and BF is the adjacent side and FC is the opposite side. So we know the Pythagoras theorem. Hypotenuse square equal to side square plus side square. In this, hypotenuse is FC. FC square is equal to FB square plus BC square. FC square is equal to FB square plus BC square. So from this I can write FC square is equal to BC square plus BF square. BC is nothing but RA and BF is R cos pi. So FC square I can write in terms of RA square minus R square cos square pi, and FC is equal to square root of RA square minus R square cos square pi. FC equal to RA square minus R square cos square pi whole power 1 by 2. Similarly PF, we already write the PF as, here PF as R sin pi, capital R sin pi. So I have written CPE as square root of RA square minus R square cos square pi minus R sin pi, and in the similar way we can write DE minus PE also. So if you common out squares and if you common out this capital R sin pi, capital minus small r sin pi, you will get this equation, and this is nothing but path of contact. Path of contact. Path of contact is path of approach plus path of research. Similarly, we can also write arc of contact. Arc of contact is nothing but path of contact by cos pi. In the next video, we will discuss about gear trains. Thank you.